Subscribe to AmpCode and ring the notification bell to get the latest content.
This lecture is all about what are the best practices you can utilize to develop your solution and what will be the next steps. But here we are also going to discuss about what are the challenges that every data engineer will suffer from and how you can overcome them. So without further ado, let's get into it. So now let's talk about some of the best practices that you can use as a data engineer. The first one is you have to enable your data pipeline to handle the concurrent workloads. So basically every data driven organizations will have several workloads to be profitable and get the business decisions on time. So your data could be coming from many multiple sources. It could be coming from any SAP sources, it could be coming from real time from any sensor or website logs, or it could be coming from as a batch data and also from the IoT devices. So to handle all these workloads, your system should be able to handle this and your pipeline should be able to handle these concurrent workloads, because some of them will be coming as a batch data, some of them will be coming in real time. So every use case, every data source needs a specific set of work in your pipeline, and many mission critical applications like real-time fraud monitoring. So in those cases your pipeline should be able to handle those workloads very efficiently and get the result on time, because the sectors like the financial data, then the healthcare information, these data are really critical and needs to be processed on time. So that's why you should enable your pipeline to handle such concurrent workloads by using the best practices and the optimization techniques that we have seen in our previous lecture. So the next thing is very important and time saving. You have to tap into your existing skills to get the job done. So basically every new requirement will require a new set of technology and also requires a new set of tools. But you should be aware that many of these technologies have way more capability than you know. So as you already know that Apache Spark has the capability to work with the machine learning algorithms using the MLlib library. Then we got the graphics to handle the graph data, as well as it has the capability of Spark streaming to able to process the real-time data. So you don't need to learn about the Apache Kafka for processing the real-time data. Then you don't have to worry about like a specific tool or technology for implementing the machine learning algorithms. So you should be aware that what skills you already have and you can utilize it with saving some time. So your resources should not have to learn new technologies. Their existing skill set will just do the work. So basically you have to just aware of all the things that you know and how you can implement it and save time and get the job done at the end of the day. The next one is you have to use the data streaming instead of batch ingestion. This is very vital. So many of the traditional data approaches requires you to handle the data which is coming in batches. So basically you will be having like a daily load or an hourly load, but many mission critical applications like the fraud monitoring, then the recommendation system requires you to process the data in real time. And many of the use cases will improve if you give this decision making capability and process the data in real time instead of doing the batch mode, because it will save us a lot of time and it will be more profitable for every data driven organization. So you should think that how you can do the streaming ingestion instead of the batch ingestion and how it can save a lot of time of the business analysts and the data scientists, because these are the guys that are consuming the data and converting your raw data into some meaningful insights. So you have to just think outside the box and not just rely on the batch ingestion, but you can easily convert them into the streaming data so that you can implement fraud monitoring, and as well as I have talked about like the recommendation system. So many of the companies like Netflix leveraging this streaming application using Kafka to get you the recommendation system. So it gets the data of your watch history and also sees the watch histories of the people who is related to you, and they can recommend that on the basis of it. So basically if your friend has interest in specific genre, then that recommendation you will also get. So here we are not talking about the recommendation system, this was just an example, but you should be thinking about converting your batch ingestion to the data streaming to get the most out of your data. So the next best practice is you have to operationalize your pipeline development. So basically, if your pipeline is able to handle and integrate with the multiple data sources, so let's say if you want to add another data source in your pipeline, so you don't have to reinvent the wheel and write the code and write your solution from the scratch. It should have the capability to integrate with the new tool seamlessly without doing much groundwork, and it can able to get the data and process it and also integrate with the downstream application. So basically, operationalizing your pipeline development is way more suitable in the agile development, where you will be having like very short sprint to deliver your task, and it will really help you to maintain the integrity as well as the scalability of your pipeline. And the next one is really important, and we have a lot of examples related to it. So basically, you have to invest in tools which have like a built-in connectivity. So as we have seen in the Hadoop ecosystem, so it has a lot of services and technologies which can work seamlessly only with Hadoop. So you have to remember that when you are adding different data sources, so if you have like different data warehouses, different data lake houses, as well as the different processing engine, then you have the different dashboard or UI which can pick the data and gets the output to your end users. So basically, this tool needs to be integrated seamlessly without any groundwork, and integrating all that will be really time consuming, and you should be having like some tools like a Hadoop ecosystem which has all these tools which work seamlessly with each other, and formats are also compatible. So let's say you should be using like a Parquet format. So Parquet format is suitable for many of the big data application and the tools. So this is the good example, as well as we have the Amazon S3 bucket. So the format used by the S3 bucket is suitable for many of the downstream tools. So you can use S3 bucket as a storage layer for your application. So you have to invest in tools very wisely, because it should be scalable enough to add more sources and integrate it very efficiently without much groundwork. So that is very important for cost effectiveness of your organization. So the next one is you have to enable the data sharing in your pipeline. So this is also very important aspect. So there will be like multiple teams requiring the access to the same data. So let's say if you have two teams working on the same data set, but their end goal is pretty different, but their source data is similar. So they don't have to reinvent the wheel. If a first team has the data pipeline already there in place, so they can able to utilize it if you have the right data sharing process in place. So you can share your data pipeline so that they can also utilize that source and build their solution on top of it, instead of doing all the groundworks from scratch and get the data to the required format. If the A team has already done it, then B team can utilize it to save so much time. The next one is you have to choose the right tool for your data processing, or we can say it as data wrangling. So basically, let's say if you have an Apache Spark which can process the data, but it totally depends on what you want to achieve. So if your data is coming from any sensor, it will have a lot of garbage values that you need to process. So your tool should be able to process that data to get that into the required format, so that it can utilize in the further machine learning pipeline or the data analysis on top of it using SQL. So your data should be in the right format and it should be meaningful. So for that, you have to choose the right tool and efficient tool to process the data, because handling the big data and processing the big data is very crucial step in your data pipeline, and it needs a lot of groundwork and great cluster management, and you have to choose the right tool to able to achieve this process very seamlessly. And also at the last, you should be having like a data catalog. So data catalog means which sources you are using, how the data is flowing, what are all the joins and transformation you are using. Every step of your data pipeline you should be having as in a data catalog. So you have to build it into your engineering strategy, because it is so much usable for end users as well to decide like if the data source is the trustworthy or not, which data source you should be using, which transformation is using, and what are all the logics and also review all the logics and transformation that you're applying in your data pipeline. And also data scientists will have to access all those sources to able to analyze that data, so that data catalog should be the only place for everyone to access the overall architecture of your data pipeline. So these were all the best practices that you can use in your day-to-day life to make your life simpler as a data engineer and implement a great data-driven solution to your organization.
So that's it for today. I'll see you in the next lecture.